po, so ngayon, i-discuss ko lang po sa inyo yung some topics of linear algebra, which are inner product spaces, also inner product, and the Schmidt process. Diretso na tayo dun sa ating inner product space. So, what do we mean by inner product space? So, an inner product on V is a function that takes each ordered pair, UV, of elements of V to a number U, or the inner product of U, V is an element of F and has the following properties. So, ang F na tinutukoy natin dito, element siya ng real number or complex number. So, dinenote natin siya as F. So, si inner product is pwede kay real number and also kay complex numbers. So, positivity. So, these are the properties of inner product space. So, V, or the inner product of V is greater than or equal to 0 for all V is an element of product of inner product space, V. Next is the definiteness. It means the inner product of V is equal to 0 if and only if V is equal to 0. So, tinutukoy natin V dito, this is a vector. Additivity, so we have U plus V and W or comma W is equal to U, comma W, or the inner product of U and W plus the inner product of V and W. For all U, V, W is an element of a vector space. Next is, we have homogeneity. We have lambda V or any constant, or lambda V and B or equal to lambda times the inner product of U and V. For all lambda is an element of real number or complex numbers, and all U and V is an element of vector space. So, we have another property. So, itong mga properties kasi ito, magagamit to if we have proving sa inner product. So, conjugate symmetry, it means that the conjugate of the inner product of UV is equal to the conjugate of the inner product of U and V. For all U, V is an element of vector space. This conjugate symmetry is applicable lang siya na ganito yung magiging property niya kapag ito ay complex numbers na pinag-uusapan. Pero kapag real number, the conjugate symmetry, the conjugate symmetry of U and V is also the inner product of U and V kay real number. It's just the same. Nagkakaroon lang kayo ng ganito conjugate symmetry kapag complex number. So, therefore, an inner product space is a vector space V along with an inner product in V. Notation, V together with yan. Ito yung ginagamit nating notation for inner product. We have yung angle bracket is called the inner product space. So for example, I have here a vectors, U and V. So, element siya ng Rn. So, Rn, yung real number. So, kung ano mang dimension. Depende si dimension, depende kung ilan yung given na element. Pagka dalawa, that is 2-dimensional. Kapag 3-dimensional. So, we have, for example, vector U and V. So, U, which have an element or elements, U sub 1, U sub 2, up to U sub n. Sorry, U sub 2 yan. And also, this one, we have V sub 1, V sub 2, up to V sub n. So, the inner product of U and V is given by, so the inner product of U sub 1 plus U sub 2 times V sub 2 plus up to U sub n, V sub n. So, example. Simple lang naman example natin. So, example, I have here a vector U which contains elements 1, 2, and 3, and then V which contains 4, 5, and 6. So, the inner product of U and V, so ayan, denoted as the angle bracket. So, the inner product of U and V is yung first element, 1, times the first element of V, so we have 1 times 4, plus the second element, which is 2, times the second element of V, which is 5, plus 3, times the third element, we have 6, equals 32. So, therefore, the inner product of U and V is 32. So, ganun lang kasimple yung process ni inner product. So, next is we have the norm. So, the length. Norm is also known as length of a vector v in Rn is given by, so, the norm of v, for example, ito muna, definition mo tayo. The norm of v equals, so, the square root of v times v equals the square root of v sub 1 squared plus v sub 2 squared up to v sub n raised to n. So, we have u equals 1, 2, 3, or we have n elements 1, 2, and 3, and then we have vector v which contains an element 4, 5, and 6. So, the norm of u, so ito lang 1 squared plus 2 squared plus 3 squared, so naka-square root. So, the square root of 1 squared plus 2 squared plus 3 squared equals square root of 14 or 3.74. And then we have, sa mga nakita ko naman sa libro, tinatanggap naman si norm na naka-square root. Next is we have the norm of v. So, we have v which contains elements 4, 5, 6. So, the norm v is equal to the square root of 4 squared plus 5 squared plus 6 squared equals square root of 77 or 8.77. So, ganun lang yung pag-compute ni norm. Ito lang yung ating sundan na formula. Okay, next is we have what we called in inner product. We have a orthogonal. So, two vectors u and v in Rn are orthogonal to each other if their inner product is equal to 0. So, kapag kinuha daw natin yung inner product ng dalawang vector, we have u and v, dapat ang sagot ay 0 para maging orthogonal. So, for example, I have here a vector u, 2 times 1, we have here the vector u which contains elements 2 and 1, and then we have vector v which contains an elements 3 and negative 6. So, kapag kinuha natin yung vector, yung inner product of u and v, which is 2 times 3 plus 1 times negative 6, ang makukuha natin ay 0. Therefore, u and v are orthogonal. It means their inner product is equal to 0. Yun kay orthogonal. Another is, meron tayong also orthogonal kapag naman na pinag-usapan ay orthogonal set. It means, hindi lang siya dalawang vectors, but we have 3 or more vectors. So, a set of vectors, in short, a set of vectors, v sub 1 up to v sub n, in Rn is said to be orthogonal set if each pair of distinct vectors from the set is orthogonal, that is v sub I times v sub j is equal to 0 whenever I is not equal to j. Consider, for example, we have set v sub 1, v sub 2, and v sub 3. So, masasabi natin orthogonal yan kapag kinuha ko yung inner product ni v sub 1 and v sub 2. Ang sagot ay 0. Pag v sub 2 times v sub 3, or inner product of v sub 2 and v sub 3, 0 pa rin dapat yung sagot. And v sub 1 and v sub 3, kapag kinuha yung inner product, dapat 0 pa din. So, masasabi natin na orthogonal set yun. So, let's try. So, for example, itong v sub 1 and v sub 2, so, the inner product is 1 times negative 3 plus 2 times 0 plus 1 times 3. So, the answer is 0. How about v sub 2 and v sub 3? Pag kinuha natin yung inner product. So, we have 1 times negative 2 and then 2 times 2, 1 times negative 2. So, 0 pa din. How about v sub 2 to v sub 3? Negative 3 times negative 2, 0 times 2, and then we have 3 times negative 2. So, kapag kinuha natin, kahit alin dyan ang pagparisin mo at nakuha mo ay 0, that is a orthogonal set of vectors. So, lagi lang natin natandaan, si orthogonal, ang inner product ng dalawang or tatlong vectors is 0. Next is, meron naman tayong tinatawag na orthonormal. When we say orthonormal, it is a list of vectors in V or in vector space is called orthonormal if each vector in the list has norm 1 and is orthogonal to all the other vectors in the list. In other words, in list V sub 1 up to V sub n of vectors in V is orthonormal if the inner product of v sub j and v sub k is equal to 1 and 1 if j is equal to k. 0 naman kapag ka if j is not equal to k. So, sa madaling salita, magiging orthonormal siya kapag ka kinumpute natin yung norm at ang nakuha natin ay 1. Kapag naman kinuha naman natin yung inner product, makukuha naman natin is 0. So, that is orthonormal. So, for example, I have here, we have U, which contain elements 1 over square root of 3, 1 over square root of 3, 1 square over square root of 3. And then we have vector V, which contains element negative 1 over square root of 2, and then 1 over square root of 2, and then 0. So, check natin kung ito ay orthonormal. So, kapag kinuha natin yung norm of U, square root of 1 over square root of 3 squared. Pangalawa, 1 over square root of 3 squared. Ganon din yung pangatlo, 1 over square root of 3 squared. So, kapag kinumpute natin, we will get a 1. So, therefore, ang norm niya ay 1 or the length is 1. Dito naman sa V, kapag kinuha naman natin yung norm, again, yung norm, yung kanina pinakita ko yung formula, ganun yung formula niya. So, we have square root of negative 1 over square root of 2 squared plus 1 over square root of 2 squared plus 0 squared equals 1. So, therefore, ang norm ni U at ang norm ni V ay 1. So, therefore, it is hindi pa natin masasabi pala na orthonormal. Kunin muna natin yung inner product nila. So, the inner product of U and V is 1 over square root of 3 times negative 1 over square root of 2 plus, ito naman, 1 over square root of 3 plus 1 over square root of 2 plus 1 over square root of 3 times 0 equals, so we have negative square root of 6 over 6 plus, ito naman, we have square root of 6 over 6 plus 0 equals 0. So, therefore, the list is orthonormal, or U and V are orthonormal. Kasi, ang na-compute nating norm ay 1 and they are also orthogonal. 0 yung kanilang inner product. So, that is orthonormal. So, what if hindi orthonormal yung given? Doon tayo gagamit ng Gram-Schmidt orthogonalization process. So, this is the formula for a Gram-Schmidt orthogonalization process. So, let's proceed to the example. So, let's have an example. For example, find an orthogonal basis span by a set of vectors. For example, I have here a find an orthogonal basis span by a set of vectors. We have x sub 1, which contains elements 2, negative 5, and 1. And then x sub 2, we have 4, negative 1, and 2. So, kukuha daw tayo ng orthogonal basis span na galing dito kay x sub 1 and x sub 2. So, ganun si Gram-Schmidt. Since itong given na to ay hindi to orthogonal, kasi kapag kinompute natin yung norm neto, hindi sila equal to 0, ay equal to 1, and also kapag ginawa natin ang inner product na x sub 1 and x sub 2 ay hindi equal kay 0. So, therefore, hindi sila orthogonal. Kaya, kukuha tayo ng orthogonal basis span. When we say span, it is any linear combination na connected dito kay x sub 1 and x sub 2. So, first step kay Gram-Schmidt, equal natin si v sub 1 equals x sub 1. So, let x sub 1 is equal to v sub 1. And then also, v sub 2, para makukunin kasi natin dito yung v sub 1 and v sub 2. So, v sub 1 as is natin, equal natin siya as x sub 1. And then, the v sub 2 is ito yung formula na gagamitin natin based dun kay Gram-Schmidt process. So, x sub 2 minus x sub 2 transpose times v sub 1 over v sub 1 transpose times v sub 1 times v sub 1 equals, so, substitute lang natin. So, x sub 2, at x sub 2 natin, so we have 4, negative 1, and 2. And then, we have x sub 2 transpose. So, i-transpose lang natin. This is a column vector. Gagawin natin siyang row vector. Transpose. Times we have v sub 1. So, ang v sub 1 natin, di ba dito nilagay natin, equal siya kay x sub 1. So, ang v sub 1 natin is 2, negative 5, and 1. Over, again, v sub 1 transpose. So, v sub 1 is, ito, 2, negative 5, 1. Since equal siya kay, x sub 1. So, transpose, ito yan yung formula ha. Therefore, ginawa lang nating row matrix. Row vector. And then, times v sub 1, which is also x sub 1. So, 2, negative 5, 1. Times v sub 1 ulit. So, we have 2, negative 5, and 1. Equals, so, copy lang muna natin si 4, negative 1, and 2. Minus, so, pag sinimplify natin to, itong taas, and then baba, makukuha natin 15 over 30. Negative 15 over 30. Times, ito, hindi ko pa simplify, we have 2 times negative 5 and 1. X. Multiply naman natin to. So, copy lang muna natin si 4, negative 1, and 2. So, 15 over 30 times 2, negative 5, 1, we will get 1, 5 over 2, and then 1 half. Equals, kapag pinag-minus naman natin to, makukuha naman natin is 3 halves, and 3 halves. So, therefore, nakakuha na tayo ng span of v sub 1 and v sub 2, natatawagin natin W. So, ina-note natin, ililat natin as W, which is the span of v sub 1 and v sub 2. So, kukunin lang natin, ang v sub 1 natin, diba dito, is yung x sub 1. So, copy lang. And then, the v sub 2, ang nakuha natin sa v sub 2 is this one. Ayan. So, ito yung ating v sub 2. We have 3. Ayan. We have 3 negative, 3, we have 3 halves, and 3 halves. So, yun na yung ating magiging v sub 2. So, meron na tayong v sub 1 and v sub 2. Which is si v sub 1, yun pa rin. Si v sub 2 lang yung nagbago. So, next naman natin, hindi pa yan yung final. Meron pa tayong next step. We have, ito na, kinopya ko lang yung span natin kanina. We have 2, negative 5, and 1. 1, 3 halves, 3 halves. So, kukunin natin yung norm ni v sub 1. Ito. And then, so, kapag kinuha natin yung norm, apply lang yung formula. 2 squared, negative 5 squared, 1 squared. So, square root equals square root of 30. And then, pag kinuha rin natin yung norm ni v sub 2, which is ito. So, we have square root of 3 squared plus 3 over 2 squared plus 3 over 2 squared equals square root of 6. And then, every element ni v sub 1 ay i-divide natin sa nakuha nating norm niya. So, magiging 2 over square root of 30, negative 5 over square root of 30, 1 over square root of 30. Ganun din kay v sub 2. So, therefore, v sub 1 divided by v sub 1 equals, so, babalik tayo dun sa ating v sub 1, which is 211. Balik tayo dito. Ba't 211 to? Okay, so, next naman natin is, note, dito muna tayo, si 1 and 3 over 2 and 3 over 2, pwede natin siyang ma-lowest term, which is 211. I-divide natin sila lahat by 3 over square root of 3 over 2. Ulit. So, again, itong v2 natin, v sub 2, lowest term lang natin. All elements ay i-divide natin by 3 over 2. Since divisible sila pare-pareho by 3 over 2. So, 1 divided by 3 over 2 is 2. And then, 3 over 2 divided by 3 over 2 is 1. Ganon din itong dulo, which is 1. So, ngayon, itong 211, yung i-divide natin sa norm niya, which is square root of 6. Kasi mas madali yun. Kaysa dito 3 over 2, mas complicated siya tingnan. Since span naman to, ibig sabihin ni span, any linear combination na connected naman, pwede. So, therefore, magiging sagot natin is 2 over square root of 6, 1 over square root of 6, and 1 over square root of 6. So, ngayon, meron na tayong span. Kukunin mo lang to, which is your v sub 1, And then, ito na yung magiging b sub 2 mo. Therefore, we have b equals span 2 over square root of 30, negative 5 square root of 30, negative 1 over square root of 30, and we have 2 over square root of 6, 1 over square root of 6, and then 1 over square root of 6, which is, this is the span of yung una nating given, which is x sub 1 and x sub 2, which is, this is the orthonormal basis of our given given set of vectors kanina. So, 2, negative 5, and 1, and then x sub 2 for negative 1 and 2. We have, we get the orthonormal basis, which is this one. So, ganun lang yung process ni Gram-Schmidt. Okay, so kapag kinuha natin yan, kinompute natin, makukuha natin na norm niyan ay 1. Makukuha rin natin na inner product dyan ay 0. So, yun, nagkaroon tayo ng orthonormal basis. So, that's all for inner product and orthogonalization. So, I hope naintindihan nyo po. Yun lang, and thank you so much.